Okay, let's get started. I heard you had a lot of fun in the other room. Now we are going to have fun with something that I really like as a developer. Finally, we are becoming serious about having JSON in database in Azure SQL and SQL Server. So I really want to show everything about what we have done in the year, what we are been doing, and what you can do as a developer, because now JSON really kind of bring a little bit of flexibility and options to our database design. I'm Davide Mauri. I'm a PM in the Azure SQL team and SQL Server. Lately, I'm mainly working on AI and vector stuff, but I also am very close to the developer experiences and features. So that's why I'm presenting about JSON. And then you can reach out to me and follow me on LinkedIn, Twitter. I blog quite a lot about the features that we release. So if you want to stay updated on all the features we release and all the things we do, just make sure that you follow me on devblogs.microsoft.com/Azure SQL. It's a blog where me and all my colleagues post about developer-related stuff. And of course, there is also my website where I can find all other resources, GitHub, and everything. This is the very well-known slide, so make sure that you fill the session survey before the end of the session. Now let's move to the agenda. So very, not that the short history of JSON and SQL Server to make sure that we are all on the same page regarding the feature that we have been adding to the engine over the years. Some are really nice. And then we are going through what is new in SQL 2025, which is a lot. And then some information, some discussion on how to use JSON in SQL Server in your application, or Azure SQL in your application. So let's start with a brief history. In 2016, we added support to JSON in terms of just functions, because JSON were still, and you can still do it today, you can store JSON just like a string, so an nvarchar. But then we added a specific function to understand if text is actually a JSON, extract a scalar value from JSON with JSON value, extract objects from or arrays from JSON using JSON query, or even modify JSON so you don't have to move it outside database and then bring it back. And then we added two very interesting relational operators. It really kind of brought quite of an interesting perspective to JSON. Basically, OpenJSON allows you to take a JSON document and interact with it like if it were a table. And for JSON, do the opposite, allows you to take a query, a result set in rows and columns, and return it as a JSON document. So these are very nice because especially in JSON, yes, it's true that it has a flexible schema, but at the same time, it's also true that the majority of the times you will have a recurring schema, especially if you have a JSON array. And for example, for orders, you will have always the number, always the date, always the count number, and so on and so forth. And the next object in the array will very much likely have the same properties, right? So it's very nice to see this also as a table. So it would be nice to be able to do select star from OpenJSON and then define what is basically the schema that you want to use to extract the data from your JSON, which is also defined today as a schema on read. And basically you say, yes, I have a number property that I want to have mapped to a number column, and so on and so forth. And there you have a table. And you can from now on, manage the content of JSON as a table, which allows you to join with other tables, filter it using regular where predicates, and so on. The other way around is that as a developer, it's very convenient to have the result returned as JSON, because I can just use it and it's very easy. I can serialize and deserialize it if I want, or I can just send it to my JSON, to my JavaScript frontend, maybe as JSON, so I can show it in a nice UI. And that's exactly what I can do with for JSON. So if that is my table, I can do the easiest option I have. Of course, you can fine-tune how you want the JSON to be emitted to a certain level. You can do select star or select columns from the table for JSON auto, which means that we'll automatically take every column and use it to set it as the key name, and the value of the column will be the key value. And of course, we'll do it for every row in your table, creating an array of documents. So very nice, very simple, very elegant to start to think of using JSON as a transport, other than maybe an option to store data in a database, as a transport from my backend to my database, and from my database to the backend to simplify developers' life. Now, that was true in 2016, but again, the main problem was that JSON was handled, but you cannot really store JSON as JSON. It was like a string, so you couldn't create an index or a native index on it. It wasn't very easy to use maybe complex predicate to search. Give me the document that has an array in which there is value 1, 2, 3, right? You couldn't do that. Not easy, at least. So we started improving the JSON support, and in 2022, we added 2 super interesting features, the function JSON object and the function JSON array, and then we added another one, a utility one, that allows you to figure out if a path exists in your JSON document. You don't care about the value, you just care if the path exists or not. So that is okay, but the other 2, JSON object and JSON array, are really powerful. Because before, with for JSON, even if you have for JSON auto, which is the default option that I showed you, the easiest one, and then you also have another option more powerful called JSON path, for JSON path, where you can actually change the name of the properties, so you don't have to always use the name of the column. But it was limited. For example, what if you have a value in a column and you want to use that value as the key name, not the value name? Or maybe you have the key name in a variable. Well, you couldn't create the key based on something else other than the column name itself in the past. In 2022, with JSON object, you could, for example, have a variable, let's call it email key, that contains the name that you want to use as a key in your JSON. And then you build the object using the JSON object, specifying a key value pair separated by a colon, and then comma, and you go on, and you keep going on to add as many key pairs as you want. Each key pair can be a simple scalar, can have a scalar value, or can be another JSON object itself. So for example, contacts, you are adding another JSON object in which the key of one element is basically generated using the value of the variable, and the value is also generated by using a variable. Of course, I could have also used columns, right? So this makes the ability to generate JSON very, very flexible. Basically, there are no JSON that you cannot create anymore. Any JSON shape can be created. And also you have JSON array that allows you to create arrays from a list of value that you specify. So this code would generate this JSON, right? So the first name, last name, and roles specified because I specified the values. The email key is taken from the variable. The email value is taken from another variable, and so on and so forth. And the contact is actually an object itself. And that was already a huge step forward because, again, you could basically generate any shape of JSON that you wanted. Then we, after a lot of push from developers, so thank you for the feedback, we were able to finally do the right thing and add full native JSON support in 2025. Because in SQL Server 2025, and before that, recently, we released in Azure SQL Database and Azure SQL MI, and of course also Fabric SQL, a native JSON type. Native JSON type means that the JSON that you store in database is not stored as a string anymore. It's represented as a string when you want to access it, but internally is a very efficient JSON format. Internally we call it MS JSON format. It's not Bison, it's not JSONB, it's something we created to make sure it perfectly fits the engine of SQL Server and overcomes some of the limitation that other competitors has. We also added the ability to aggregate JSON, which means you can have a group by, and just like you can have a string aggregate that will concatenate the value that on which you are doing the group, you can now use JSON object aggregate and JSON array aggregate to take a table and using a group by clause, decide which goes in which array and which goes in another. So array aggregate and an object aggregate are very powerful when you have to maybe generate one single JSON document out of many rows with different grouping logics. Then we have additional value to JSON, additional enhancement to JSON value, especially to better support indexing and cases where JSON is not homogeneous. So for example, you have a property called ID that sometimes contain an integer and sometimes has contain a string, right? And that will pose some challenges for us at the moment you want to cast it to an integer. So we add that is a returning clause, and everything I'm saying, by the way, is NC compliant to make it easier to correct to return the data type right from when you extract the value, so you don't have to cast it after. You will see everything in a session, in some demos I prepare. And then another one of my favorite, we finally now support path expression within JSON queries. So let's say that you want to extract some value, but the value you want to extract is the third in a JSON array. Before you couldn't do that, right? You couldn't do that in a native or an easy way. You had to explode the JSON, write a where clause, very complex, very weird. Right now it's very elegant. Let's say you have an array of phone numbers. You want to have all elements. You will just say I want to have all the elements with the star, meaning I want to access all the values in the array. Or I want to have the first and from the first to the second element, so 0 to 1. You have ranges that you can express. Or you have exact positions. I want to have the number at position 0, so the first, and a position 2. Or you don't care about what is the position, but you really want to have the last element of the array. So we added a kind of literal called last, which will point you to the last element in array, whatever is the length of the array. So very nice, very easy to access exactly the element that you want in a JSON array. And then, of course, we finally added, as I said, the JSON type. So everything I just shared and presented works on everything, but also in the JSON that we support we already had. But now we have a specific JSON type that, as said, stores JSON in a native binary format. Basically, it solves the problem that every time before using this type, every time we access the JSON values contained in a string, we couldn't be really sure that JSON was JSON. So we had to parse it, right? And parsing JSON, it's expensive. And we had to do this every single time JSON was accessed. Now, the situation is the opposite. We just parse the JSON once it's written in the JSON column, and then from that point on, we know it's going to be JSON by definition, because that's the column constraint. So it's very fast once you have the JSON inside the table to read and parse and process and access the JSON once it's been parsed. It uses a lot of capabilities of large object binaries, so you can store up to 2 GB of JSON. It's not that I'm recommending to do it, but if you want, you can really have fun with it. Other databases supports way less smaller sizes. For example, Postgres is limited to 155 MB, Oracle to 32. We go up to 2 GB. Again, I'm not recommending you to always go and store 2 GB of JSON in a single row, but if you really need to do it, you can. Of course, we also allow you to do in-place modification that are kind of a important difference between what we are doing before and we can do with the JSON type that I'll show you when we talk about modification. And then, of course, we finally support also proper JSON indexing. So you can create a JSON index on your JSON document to have a quick access to every property and value in your JSON document, because it's indexed. So we don't have to traverse the document every single time, because the data is indexed and basically the values are already exploded in an internal table. Then we added a new function, and this is one of my favorite. It's called JSON contains. It's basically a function that allows you to understand if the JSON contains some specific value. Maybe you are not interested in extracting that value, but you want to find all the document that contains the phone number XYZ. Before, you had to extract the value using a JSON value and then use a where clause. Now you don't have to do it anymore. And of course, this will also help index to be even more efficient, because we don't have to basically extract data from JSON. We can just look at the JSON and see if it has what we need. And in fact, the best practice is to move to use JSON contains. If you can write basically the same query you were running using JSON value on JSON query, to use JSON contains, because that, you will see, will enable a much more efficient and on-point usage of the index. Now, this is all about SQL, but we are all developers here, so you're probably interested in, this is all great, but if I can't use it from EF Core or from, the SQL client, it's useful, but not that much. Well, so you will be happy to hear that we, of course, already added native JSON support to the Microsoft.data.SQL client, so the latest and greatest SQL client. We already are 6.10, but if you have 6.0.2, you already have full JSON support. So there is a new SQL JSON class that allows you to read the JSON and return the data as JSON, not as a string. And of course, you have the get SQL JSON if you're using a reader. I also added the native support to JSON to JDBC if you're a Java developer. And in general, what is happening behind the scene is that we take the JSON that is formatted as a binary object inside the engine, we transform it into a UTF-8 string, and we stream the string as of today. So you don't have much performance increase compared to how we were sending JSON before, because at the end of the day, we are still sending a string. This is mainly for compatibility issues, especially, for example, if you're a Python user, you don't really have to worry about receiving some binary data. You always receive a string. And usually it's fast enough. Again, JSON is definitely not the thing you use for having fast performance, so we favor the kind of flexibility and compatibility over performance here. But we created a SQL JSON class and the related Java class to make sure that you don't have to cast or parse the JSON yourself again. On the driver side, you can just use, for example, a JSON text reader or whatever you have in .NET or Java. Here it's basically a table comparison of what offers the new JSON type compared to what offers the legacy JSON. Legacy means JSON stored as a varchar and varchar and the likes. And again, basically it boils down to having the parsing done once during the insert, as opposite to having the parse being done every single time we access JSON when we read the data. And of course, in general, the binary format is also more efficient from a storage perspective. So there are some exceptional cases in which this is not true, but on average, you should expect a more compact storage for what concern JSON stored in your database if you use the JSON type. And basically, those are the main two important things. Having said that, let's see it in action so we can have a sense of what this means for us as a developer. So let me start with a sample database. First of all, it's the font also big for those in the back? Show me. Good? Okay. So I'm creating some sample tables where I want to store information about people. And I will go first using a kind of a relational type schema. So I have my users table where I'm adding some users here. And then, of course, for each users, I have one or more address. And then in the address, I have also information. And then, sorry, I have another table with the phones. And of course, I have more than one phone for each person. And then I'm trying to do the same, so we can compare, basically saving exactly the same data, but in a single table where I just store everything as JSON, just to see how it looks like. And basically the JSON is something, actually, I have it here, is something like that. I have a document that contains first name, last name, all the other properties. Address it is a one-to-one relationship between my person and my address, so it is just a single object. And then phone numbers, it's 1 to n, so I have an array of objects here. And of course, I have a couple of rows here or documents, two very similar, and one that contains, interestingly, itself is an array. So the third element is actually an array of documents that represents my users, just to see what happens, because this is the typical case of JSON, that you have a kind of a flexible and kind of a dynamic schema. So let's see how SQL handles that. So let me go back to the setup, make sure that I added everything. Actually, you know what I can do? I can just, the whole stuff here, And I'm using the SQL Server 2025 CTP 2.1, which is available to everyone to download. You can download it very easily. If you have Visual Studio Code, as I'm using right now, there is an extension called MS SQL. Let me show it to you. It's quite interesting. So if you download the MS SQL extension, that's the first one, you will get basically this little icon here, SQL Server. If you click on this icon, it will automatically ask you, if you have Docker installed, it will automatically download the image of SQL Server that you want to use. For example, the latest one, 2025, it will download the image for you, run it in a container, and the image will be the developer edition, which is the only one that we publish at the moment since we are in preview. And then you will have a SQL Server 2025 up and running in a minute. That's exactly what I'm using, and that's why you see my server here with the Docker icon, because that's exactly what I did. So I went and created a new server using the new container option, downloaded SQL 2025, and I'm ready to go and show you the JSON stuff. So let's start querying JSON. So the first step is that we want to extract, and let's keep this on our side. So this is basically what I stored in my database, right? So let's keep it on our side. And let me move this here, so we have a nice side by side. So I want to extract the JSON value, and right now I'm just focusing on one document. So here I'm saying, let me show you actually the table more than the. Here we go. So I have the JSON document stored one each in its own rows. So the first one contained the data about John Smith. The second row contained the data about Maggie Doe. And then the last one contained the data with the weird, if you want, or the array of document itself. So let's see how it works. But to start with, let's focus on just the first document. So for now, we'll be using, as you see here, I'm just focusing on the first document, right? And the first document is basically John Smith. So let's keep this on the side, as said before. Move here, so you can see the value. Okay, thank you. So JSON value allows me to extract the value from a property. Then I have if I want to return the value as an integer and not a string that I can then cast as an integer, I can use the new returning option that will return a string here. If I want to get the last phone number, for example, I can now use this path expression where I can say, give me the last element of the phone number array, and specifically, I want to have the number value. So this will work perfectly right now. Here you go. This is the last one. So very elegant, much more simpler than what you had to do in the past. Now let's see what happens if I want to extract not a scalar, but a bunch of things, like maybe an object or an array. So let's take a look at how can I get the entire address object back. I need to use the JSON query, because otherwise the value would expect a scalar, and this is not a scalar, so it will return null. But with address, I can return basically a sub-JSON object. In this case, I'm extracting internal object. I can also return the phone numbers, right? So the array of my phone numbers object, again, always with JSON query. And this is everything except the usage of this last option that is available right now in 2025. Everything I'm showing is available in SQL 2016 and 2022. Now let's start to use the cool stuff, as you already saw using the last kind of literal, but now you can use path expression. So for example, I want to have all numbers extracted from my array. So I do JSON query, and it's null. Something is going on here. Remember that before I just requested all phone numbers, and it was working. It was returning an array of objects. Now why, if I ask all the numbers and just the number value, this is returning nothing? Because that's what is going to be returned is not a JSON object. Because JSON requires that if you have an array of value, the value are separated by comma. And here, there is nothing saying that we want that, right? So you need to use the new option with JSON query and say with array wrapper. That will assure that the result is actually added into an array with a proper punctuation, and then you will have the values. Otherwise, ideally, what this first query would have returned would have been something like that, right? Because I was just asking for the numbers. So that is what was returned before, but that is not JSON. So therefore, we just try to convert into JSON and it cannot happen. So instead of erroring out, we return null. So that's why if you know you are getting multiple values, the only way to store multiple values in JSON is with an array. And so that's why you need to specify the new option with array wrapper. It's very key if you start to use the star qualifier for the path expression. So that's a very easy way to extract all the phone numbers from your JSON. Or maybe you only want to want the first, from the first to the second. So you want to have there's two numbers here, the home and the office, and of course you can say 0 to X or X to Y, and that will return these two numbers. Or you can use yeah, that's the same, so I don't know why they did that. Definitely the other thing I want to show is this one. You just want to have the first and in this case the third one, because index are 0 base, so you are exactly asking the first and the third, not a range, not all between. Or you can just access the last in this case, which happens to be the item number 2. So here, and as you can see here, I am returning in this case the entire object. Oh, I think that was the difference. Nope. So here I'm returning the entire object. Of course, I could do, let's say, type, and that will return just, need to go value here, and that will return just the mobile, right? So it's very nice. With the path, I can really do everything I need. In this case, I'm basically turning everything from the first to the last element. And of course, again, it will work very nicely. The other option I can do, if I don't want to extract every single element on its own, I can just say, okay, you know what? Take that JSON document, and I want to have all the keys and the values on their own in each row. Here you go. So each element is presented as a key value pair, and you can see the key on the key column and the value on the value column, plus also you have information on what is the value. Is a scalar, in this case is a string, is a boolean, is a number, it's an object, is an array. So you have the full information of what is each key value pair. And of course you can also select a subsection of the JSON, a sub-object. In this case, I'm extracting, again, key value pair only for the address object. So here, very nice, I have the keys and the values listed here as rows of a hypothetical table. But then what happens if you want to start to rename maybe the object? Instead of using first name with a lowercase, you want to have first name with all capital cases, and then maybe you also want to have the state in the same table, and that where you want to have the first and the last name and the other, but the state is on a sub-object. Well, you can just specify after you define the schema of how you want to read the JSON. After the type, you specify the path that SQL should use to access that value. So if you don't specify this, it's implied that the path is accessible using the same name of the column you are going to have. Otherwise, you have to specify it. Of course, JSON is case sensitive, so that's why I'm specifying it right now. And now I can have a nice table where I have the last name, the first name, and the state extracted from my single document. So very nice. Again, a lot of power here because you can really extract all the data that you want and not anymore. Of course, it also works on the arrays. So let's say I want to extract all the phone numbers of this John Smith. Again, I will do open JSON, specify the object I want to open. In this case, it's an array. So type and number will be my column. And automatically, SQL will generate one row for each element in the array. So again, very nice. Nothing new here. This was available again in 2016, 2016, 2022, and of course now in 2025. Now, let's start to do some more interesting stuff. I always worked on a single document right now, but I have more than one because I have a document in all my 3 rows. So I can use cross apply to say open the JSON that exists in every row in the user JSON table. So remember that the user JSON table contains 3 rows here. And how many documents there are in 3 rows? 4. The first row contains one complex document. The second row contains another complex document. The third row contains an array of 2 simpler documents, right? So in total, we have 4 documents here. Is SQL able to extract them all in just one query without doing complex stuff? So here I'm saying read the user's JSON table that has 3 documents and extract all the phone numbers. Now in this case, the phone numbers belongs only to 2 documents because the third one doesn't have phone numbers. But as you can see, it's able to iterate all over the rows and for each row, open the JSON document and extract the information that we ask it to extract. And of course, I can also extract the first name and the last name. So let's see what happens now since I have the third row contains 2 items, right? So as you can see, this is the ID of the document that I also extracted for the demo purposes. So I'm extracting the first name from the first document, the first name from the second document, and all the first name from the third document. And since I have more than one document because it's an array, I still have all the values that I need to extract from my JSON. Again, the query is very simple, very elegant, and works perfectly well. Now, what happens if I have a complex situation where I want to extract the first name and the address? Again, the same thing here. I can say, for example, let me close this one. I can say take all the rows from users JSON and then open the JSON that you have in each row, and the phone number, extract it as a JSON itself. Because then I want to extract the type and the number for each phone number. So here we have a kind of a nested JSON situation that I want to explode as much as possible. And of course, this is working perfectly. And as you can see, I will have a bunch of rows because it's kind of a denormalized situation. So for each phone, I have a repeating value of basically the row that pertains to JSON Smith, because one row contains a single JSON document that has only one first name and last name, but many phone numbers. And basically, it is like joining the different tables if you had store the data in a relational format instead of JSON. But JSON captures information about the relationship also by just nesting the values. So that's exactly how you can see it transformed into a table. So all the phone of this JSON John Guy are available, and all the values that are applicable to this phone are repeated, just like if you are doing a join of the user table with the phones table. So very nice, and this is where we were, except for the path expression up until 2022, SQL Server 2022. Now let's move to what you can do in 2025, and as said, now we can start to use this JSON contain thing, which is fantastic because maybe I want to find all the rows in which the JSON document contains this phone number in the array phone numbers. I don't care where, as long as that phone number is in the array. So this was very hard to do before 2025 or Azure SQL. Now it's very easy because, first of all, let me execute this and connect them. Thank you. Now it's very easy because you just say, hey, can you return to me all the rows that where the JSON document contains a phone number somewhere here that is equal to the 0986 number. Fantastic. So I can write a query that says, hey, I really want this phone number to be the first, or I want this phone number to be in one or from the first to the second element, or I want to check if this phone number is the last one. Of course, in this case, this phone number is not the last one, and so it doesn't return the value because this number is actually not the first is the second, if I remember correctly. And in fact, now in this case, we have the result because my phone number exists between the first and the second element, but it's not the first and it's not even the last. So that's why I can find it using JSON contains. So JSON contains is very, very elegant, very powerful, especially when you are only looking for the existence of a value, not interested in value per se. Now, what about modifying JSON? Again, in before 2025, you already had the option. And let's say I start with this JSON. I can update an existing value. For example, replace the first name with Dave, or insert a scalar value, or insert an array, or append a value to an array using always the same JSON modify option, simply using a specific way to replace or append stuff. You can add an object, remove an object, so all stuff that you can already do. But what this JSON function is doing is reading the JSON, so it's reading the JSON, parsing the JSON, loading the JSON in memory, doing the change, and then putting it back, which is kind of complex and long process if you want to do many modifications per second. So that's why in 2025, we added a modify option. So let me make sure that we have the data that we need. Let me add to the user's JSON a new element that only contains first name and last name. And while I can do this perfectly, so I can say update and set JSON data equal JSON modify. So again, what is happening here, that SQL is reading the JSON, modifying it in memory, and then saving it again in database, which works perfectly fine, right? But it's expensive in terms of usage. Now you have the JSON data dot modify, which accept exactly the same parameters, so the path where you want to do the modification and the value. The difference is that data is changed in place. It's not read into memory, or it's not that the JSON is parsed, read into memory, changed, and save it back. We just go and change the value in the JSON binary representation that we have in database. So it's much, much, much faster. This only works on a column. You cannot do modify on a variable because variable is not persisted. So that's why modify only works if you are working with a JSON column. This should also work, so you should be able also to append stuff. Basically, everything is supported by the JSON modify function. Is in theory supported by the JSON, by the modify method, but there is a bug in CTP 2.1 that will be fixed in RC0 that will prevent this to work. So if you try to use that, it will say JSON cannot be used, which is of course a bug because this should work perfectly. It has been fixed already, so as soon as we release the RC0s, which should be soon, this will be also working nicely. And of course, the result is that now the JSON has been modified because I changed my last name to yellow. And so that's for what concerns modification. Let's see what about creating JSON. So again, very simple. Let's start from the tables I have. All data now is in a relational format, so I'm not using the data stored as JSON anymore. I want to generate JSON out of my relational table. And maybe I want to generate one JSON by joining all this table because I want to generate this JSON here, right? I want to generate this thing that I saved split in different table in my database, but just for the comfort of the developers, I want to send it back as a single JSON because developer can just deserialize it in the object they have. So here we go. I can just do select and then do all the joining. If I do JSON auto, what is going to happen if I select the query correctly? Here we go. Is that all the rows selected by my where clause will be used to generate my JSON answer, which it might be what you want, it might be not, in the sense that in this case, you don't have a tabular result anymore. You just have a JSON that contains an array of the object. Each object represents the single row that would have been returned as a row, but is now returned as a JSON, and each element is the name of the column. and if we detect a JSON, a join, we know that there is basically a sub-job object that needs to be created, and we will do that for you. So we try to do the best we can with the information we have about the relationship that are expressed by the join. But of course, if you want to change something, like you want to have the isAlive and age in its own object, you can also do that, because with JSON path, you can specify a little bit more how you want to have the JSON shaped. So in this case, first name and last name are in their own object, and then there is an additional info object that contains isAlive and age. And again, in this case, you are basically saying the entire result should be a single JSON. So I don't want to have 2 rows or 3 rows, each one with its own JSON. I just want to have one big JSON document. Maybe that's not what you want, and so that's why we added the JSON object function, where you can say, okay, I still need 1 row per result, but each row should have its own JSON, and maybe I want to have the ID, and then the name and surname is as an array, and items into an array. And to do that, you cannot use the for JSON option, because it doesn't have such expressivity, but you can use the new JSON object to build the JSON in the shape that you want, and JSON array to put n element together in one JSON array. Of course, you can also go crazy and say, okay, I want to create a JSON object in which the key is created by using the value of the ID column, and that's a JSON array of objects in which I have the first name and the last name, each one with their own key. So you can really do crazy stuff and have JSON like that, and it's very easy to create, very elegant, again, with JSON object and JSON array. What happens with the aggregation? Let's say you want to take all the users and take all their phones and put that phones in a JSON array. So basically you need to write a join, but then you want to group by the user ID, the first name and last name, and each phone should not be in their own JSON document or in their own row, but should be in the JSON document generated for this guy, aggregated using a JSON array. So that's exactly what is going to happen. Very nice. So I have 1 row for each user, and each row contains exactly 1 JSON document where I have the ID, the first name and the last name, and the related values, and the phone number is generated by aggregating the value returned by the join condition into a JSON array. Very, very nice, very elegant, very powerful. Okay, of course, if you really want to do complex stuff, maybe you want to have an array of objects, so you can always aggregate JSON objects, right? So this is a little bit more complicated, but not much. And now I have, just like before, 1 row for each of my user, and the phone number is actually an array of JSON object. Again, very elegant and very easy to create, and very understandable, because it's very explicit what are the keys, what are the values, and how and what you are aggregating. Of course, you can also go crazy here and say, okay, you know what? I already have the type as information in my table, and I want to have the type as the key for the number. So you can also do things like that. Instead of having a JSON named type and number, you can have the value of the type column used as a key. And again, this becomes very elegant, very compact, and again, maybe is exactly what your developer need to rehydrate their POCO object or POJO object. So very nice. Last one, before moving to last part where we are going to see some .NET stuff, is indexing, and to do that I need to switch to SMS, because there is a bug in this version of VS Code that I have that will prevent the query plan to be shown. So it is exactly the same code, I'm just moving it on good old but always updated SMS, and let me show you why and how having a JSON index is so important. So I'm creating a completely new table. The table has an ID and a JSON document, right? Now I'm inserting quite a bunch of random JSON data, so 100,000 JSON documents, each one with an ID, a date, time, some random data, and again, an array of some random data. The array has some well-known values that you will use to play with the index. Now I'm adding some additional specific values so that I can query them and show you the index. And specifically, I'm doing something weird, a bit weird. My ID, that usually it's an integer, a number, I'm storing by mistake or for whatever reason, a number as a string, or I'm actually storing a string. Because I want to see what happens when I start to query this kind of set of data where the ID is a little bit fuzzy. Okay, let's see what happens. Let me create the index. First of all, this works perfectly. We figure out the correct data type and whatever, even if the ID has a mixed data type. And as soon as this is done, so this is exploding basically the JSON document. Should take up to 20 seconds if I remember correctly. Less, perfect. Okay, now we have all the information about the statistics, so we have 100,000 rows. Now, in order to make sure that the index is used, we are still tweaking, especially in 2025, basically when the query optimizer decides to use the JSON index or not. So right now, to make sure that the query optimizer is always used, again, this is just because this is a preview version, I am telling the optimizer, look, behave like if in this table there are 1 million rows, not 100,000, right? So I can have a deterministic results of my demo. And let's start doing something like that. I want to find all the values, all the documents where the ID is equal to 100. Now, since the ID is a string in JSON, right, I extract the value using the old method, and then I cast it to an integer. Let's see what happens. An error. Because basically I'm extracting the JSON, and for the majority, the value is 100 that can be turned into integer implicitly, but ABC cannot, right? So if you try to cast a string to a number, if the string contains a number, you're good. Otherwise, you will get exactly this error. Now, returning is a little bit better here because look at what happened. It works. Because returning works the other way around. Here, instead of returning the string and then doing the conversion, internally, we only return the value that we know can be converted into what you're asking for, right? So we completely skip the ABC, and in fact, it's not returned, but we return 100, even if it's in quote, because technically, that can be cast as an integer, right? Now, this is a little bit kind of maybe a picky thing, but technically this is not what we're asking for, right? Because we asked for the number 100, an integer specifically, and we got back a string, which I don't know, some may consider it right. Technically it's not right? It's not the perfect one. And in fact, JSON contains only returns exactly the I'm still hitting the wrong one. Only return the one where also the data type aligns with your request, right? So one is a little bit more lax, the JSON value, because basically you're saying return me the JSON value knowing that JSON values can be a string, can be a number. It's a little bit, again, lax and less rigid. But when you use contains and you specify here an integer, well, we return an integer. If you specify string, maybe using the right quotes, then we will return a string, right? So contains is more strict, if you want, in what it looks for, and that's a great thing, especially for indexing, right? Because we can't have an efficient index if the data type in the same column changes from one row to another, because then the comparison rule would change. So in fact, let me now remove the row that generates an error, and let me show you also the query plan. And okay, this was the error, so I'll skip it. The JSON value use the index that we have built on the JSON index, right? But it's basically is really returning a lot of rows here. Let me show you. It's basically returning all the rows. Yes, why? Because the only way we can use this index is quickly identifying all the values that the ID property has, returning it, doing the cast, actually trying to do the cast, that's what is happening here, and then seeing if the cast results in an integer, and then if the integer is exactly equal to 100, then return it to you. But this means we cannot go directly where we know there is the value 100, because we don't even know that if the type is the right one. So JSON value can use the index and use the index, but it basically cannot really push down the predicate. Here, in the SQL predicate, you don't see equal 100, because we can't, right? Because we don't know the data type. We cannot be certain about the data type. That's the problem. With contains, we know that you are looking for an integer, so we can push the predicate down to the query optimizer and into the storage, and now you see a proper index SQL with just one row returned. So this is much faster than JSON value, especially if you have a lot of a JSON document, right? This is the equivalent of doing a search on a regular column, right? Where we know the column, they all have the same type, and so we can therefore infer that we don't have to do cast in the middle of the process, which slows down everything. And so we can do a better job in searching. And in fact, if you go in the seek predicate, you will see that now we can actually push the predicate into the seek operator directly. And instead of reading everything and then filtering, we can only read the stuff that we need to return. So much faster. Now, the other good news about the JSON, well, of course, index, of course, it works also when you have the arrays. So there is something we can optimize. When you search for everything in an array, of course, we cannot optimize it much. So we will use the index to quickly traverse the JSON, not to actively seek the result, but it's still pretty fast. I want to show you the OpenJSON benefits that you have when you have JSON index created. Because basically, what JSON index does behind the scene is really taking the JSON values and exploding it and storing them in a sort of invisible table behind the scene. So when I do OpenJSON to extract all the values for the from my JSON document, but I really want to have only the JSON document where ID is equal 100, this is super fast. Fantastic, and it returned immediately. It took basically just 8 read, actually here, no, a little bit more, 8 for logical reads on the JSON index and a little bit more on the kind of JSON index behind the scene. But I mean, the point is that it was pretty fast. And here you can see that we are using the index everywhere we can, as soon as we can, as fast as we can. Now, let me delete the index right now. So again, let me show you the speed of this. Super fast. It took probably a few milliseconds. Now, let me drop the index and do the same thing again. So this means that for every JSON document, we have to parse it, validate it, and then we can, try to find if the document contains the ID equal 100. And it took 5 seconds, again, few milliseconds, right? So using a JSON index can also speed up a lot the OpenJSON kind of operations if you use it, because basically you are moving the complexity of parsing the JSON and extracting each key value pair from when you read to when you actually create the index, right? Just like it happens with regular index. You spend more time creating the B tree because then you're faster later in retrieving the data. The JSON index is pretty much the same, and that's the proof is that even OpenJSON can benefit from it, because when you do OpenJSON without index, we need to parse every document and open it. When you do with the index, we just read the index and that's it. It's much faster, as you saw before. Now, last thing is how you are going to use this JSON stuff. Well, my recommendation is that, and I just move forward the index because I just showed it to you. The typical use case for building an application today is, the typical architecture, sorry, is this one, right? You have a client UI that usually it's a full stack application. So the client UI sends some JSON to the backend API typically talk with Azure SQL. My kind of suggestion is start to look at JSON also as a way to simplify your life as a developer, to make your solution simpler and easier to maintain, because JSON is pretty fast also to be used as a transport mechanism between your backend API and SQL. It's not the fastest thing possible, of course, but usually if you're building a web application and you are using JSON, you already decided to favor flexibility over pure performance, right? And so the same recommendation could be done also for Azure SQL. Using JSON as a transport helps you to make your database more flexible and also easier to integrate with your application, because you can just send JSON, you can use OpenJSON to use it, and then from SQL you send JSON, and then you just deserialize the JSON in your object, and you're done. No worries about reading a table row by row, mapping the column to your properties, and so on and so forth. And basically, the data flow would be something like that. You have your application, so your application sends some, I check on the slide that is completed, so I send it to my backend. The backend, instead of issuing an update or an insert or whatever, just send JSON to maybe a storage procedure behind the scene that actually do open JSON, do whatever it needs to do, then do a for JSON to generate the output, and the output is sent to the backend, and the backend just send it to the front end, and the application is very, very, very easy to create and maintain. Now, the problem is this pattern of using JSON as a kind of a transport can also be extended a bit to also use JSON as extension mechanism in your table. Let's say that now you have a new property that needs to be added to your front end. Order, very easy. You change your model on the front end, you change your model on the back end, it's done. Then you have the friction, if you want, that you also have to change your database to add a new column, which is perfectly fine, but maybe you are moving fast, you are in a startup, you don't really have clarity on the model, and you keep adding new properties every hour. So also updating database might be kind of an additional work that you have to do, or you simply don't know what properties will be there because it's the end user that will define what properties are there, because you allow extensibility to your solution to the end user. Well, I have a kind of several solutions to solve that, but the one I like at most, and I'm showing the one that you can use using Entity Framework, is that the Entity Framework is now aware of JSON. So you can set up your Entity Framework. Here I go to the DB context to say, hey, I want to have my to-do entity object that typically has an ID, a title, and a completed property. I want to be able to support some extension, and everything is in this class. I want to save it in a JSON column. So right now, let me show you. It is all commented, so there are no additional fields, right? So let me just quickly start. And I think I already have some data in here, so just let me check. Is this one? Yes. So let me go to database, sample data, run this query here, and fantastic. I have actually, no, let me delete. Let me, but we can, no, let's keep it. Let's keep it, and let's see what I have here. And this one, no, okay, let's delete everything. I just want to make sure that I show you all the good stuff. Okay, nice. So I have, let's say I have a table that has the ID, the to-do item, it's completed or not. These are properties I know are always there. And then I let my user extend my metadata, my schema, by saving some of the additional information like the order or when an item was created or the tags in my JSON. But I want EF Core to be able to handle that. So on my developer side, I don't see things managed as JSON. I just see properties in my class. So let's see what happens if I start my application And my code for now doesn't have knowledge of this additional option I added, right? So let me just just run my application. Then I can just do a simple HTTP request to see all the elements I have in my database and how they are returned. And keep in mind that my little application for now doesn't have any knowledge about the tags, about the created on properties, and so on and so forth. So as expected, when I query something, I only see the values that are mapped in my POC object, right? The ID, the title, completed, and the URL. These are the properties of my class. Now, let's say I want to add the order. And I don't want to add an order column in my database, even if it's very easy to do and you should not be worried about that. But let's say you have the need to have a very dynamic schema. So let me stop my application. I just want to make the change to my application side. So I'm going to my POC object here. Let me close this. I will say that my to-do object has all these properties. But I don't want them mapped directly to my class, because all these properties should be saved in my extension column, and my extension column has these properties here that will not be used directly by anyone, but each property will be then serialized in a JSON object named order, named author, named created on, named tags in my JSON column. Why? Because I specified that my extension object is saved into the column named extension, the one that I have here. Let me execute this again. This one, where I want to have all the properties that I can add after I, built my database, nicely stored in JSON. So now let me compile again and run my application, save it, run. Again, I haven't changed my database, so let me run it. And in a few seconds, and then we can wrap up the session. I can go here, ask for get all the information from my table, and now I have everything here. Now let's add another element. So let me add this one, and I'm adding the author and the order that are not column in my table. So added. Let's see what happens on database. Let's go here, run. You will see that now the new to-do. Here we go. The author and the created on, well, it's null because I haven't specified. There is an order that I specified in my sample here. So it's very nice because I can add new properties to my application, just changing the model on the C# side in this case, and everything will be automatically sent to my JSON column. And now you understand that since now I have JSON support for indexing and everything, if I even want to search in that column, it's going to be fast because we don't have to parse the document every time as we had to do in the past. And as you see before, it can be as fast as storing the same data into a proper column. But this gives you more flexibility, especially when you need to change many times maybe your model. So very cool. From a performance perspective, sending JSON is very, very fast. So you can basically pack a bunch of rows into a JSON array, send them to SQL. It will be pretty fast. Not as fast as doing bulk insert, but faster than just maybe doing 1,000 of insert on its own. It's much better to take your 1,000 rows that need to be inserted, pack in a JSON, send the JSON, and then using OpenJSON to basically do the insert from OpenJSON. So again, you optimize the transport at once. Okay, now using this JSON technique, you can really go very, you can scale out a lot. And an example here is a simple endpoint that was able to handle on a 4V core for business critical 15,000 users and 20,000 requests per second, all sending JSON back and forth to database, just as a proof that even if you use JSON, scalability is not an issue. You can scale as much as you want. That's it. There are some additional information here related to another example you will have in the reference in the slide, where you can actually play a little bit with options where in order to make your schema a little bit more flexible. One option is the one I show using a hybrid table, or you can just use JSON right now. You can have created a table that has ID and document, and that's it. That's another option. Or just using a classic table and do alter table, alter column, add column to basically have a dynamic schema. Some information about the schemaless if you want to go down that rabbit hole. What is schemaless exactly, and also how Martin Fowler, for example, described the schemaless approach. I just added as additional information you may want to go and read, because I think it's a very interesting debate. And having said that, any question? Are you already using JSON? Hopefully, yes. Yeah. So, question there. You just alter the column if you want. Maybe don't do it right in production. But yeah, it's as easy as basically, or doing an in-place alter, or you create another column, do the update, check that everything works as expected, and drop the column, rename the column, and you're done. How many rows do you have? How big is the JSON? Do you have 2 GB for each row? That's going to take a while. If it's very small, depending on, it all depends on the I/O, basically.
Does it matter if the types are all, or the objects are all different? Like, or do they have to be uniform?
Yeah, so there is any performance implication of doing the conversion if my column contains a JSON that every JSON has a different schema, or it's all the same? It's all the same, because we don't have idea of the schema. So we just have to open the JSON, and each key will be saved in its own row, each value with the adjacent key, and that's it. So it shouldn't be kind of something you should worry about. Yeah. Yeah. Oh, yeah. By the way, I already sent the slide to Danielle, so you should be able to download it. Oh, sorry, here. But the attribute right now in, what is that? This one. If you go into the B context, this is the regular kind of thing that you have to do in order to say, entity framework, this column is JSON. In Entity Framework 9 and SQL 2025, you have to additionally specify that you really want to use the new JSON type. Right? Otherwise, it will revert to use the nvarchar max, because that's the most compatible at the moment. But if you want to use the new JSON type, you just say has column types JSON, and that's it. You're basically forcing it. Yeah. Any other question? Okay, well, I hope you enjoyed the session. You start to use JSON more, especially with SQL, because I think it basically remove any gap that we have with other databases, and then yeah, let's go and build fantastic application. Okay, thank you so much.